I fitted the new A5 control board into this thing, and it is better, but it's still not working. And I'm starting to get to the point now as this is beyond economical repair, really. I hate to say that because I want to get it working. I want to prove that I can get it working, but unfortunately I've spent over £100 on a board that's improved matters. What that board has allowed me to do is see that there is actually now a fault with one of the input amplifiers. When I swap channel 1's input boards, it moves the fault from channel 1 to channel 2. This is why we've got at the moment front end fails on channel 1, whereas normally we had channel 2. So I need to look at that input filter, see if there's anything on there I can see obviously wrong with it. But it looks like it's going to probably need that board replacing if I can get hold of one, which I'm not sure I can. And also it looks like there's possibly, it still says there's a calibration source that fails. Now, we were looking at some of the timings on the earlier videos and they didn't look quite right, so I'm still wondering if that digital source board has got a problem. And unfortunately, if that is the case, it's basically going to write this machine off, because I've probably spent £300–400 on it by then, and it's probably only worth about £500 anyway, and that's in good working order if I ever get it in that condition. So yeah, it looks like the main problem is going to be this board here. I'll show you the board it is, and it's the main input board. When I swap this from channel 1 to channel 2, the fault goes with it. And this is basically, this takes the front end information and feeds it all into the digital analog converter, which is the board next to it. And it seems to me if I swap this board over, the fault moves from channel 1 to channel 2. So there's clearly a problem with this board. Now what I was going to do is do the obvious things, look at the input and check a couple of these chips to see if I can see anything obviously wrong. I know this board is DAF, I've got a good one to work with, so I've got a comparison which is quite nice. But really at the point now I'm starting to think, is this worth spending any more money on, and any more time even, you know. I've lost the interest a bit with it as well actually, after waiting for the last board to come and doing other things in the workshop. I've gone off the boil a bit with this. It's a bit frustrating really, because I'd love to get it working, but you know, you just can't keep spending it's £100 a pop for bloody circuit boards. You can plug a board in and it doesn't work. As I say, the A5 board that I have replaced does seem to have cleared the woods from the trees basically. There has cleared some of the faults away. I haven't got the ADC array error thing like that, so that I think that digital board was damaged. But I'm starting to wonder how much further do we go? How much more of the instrument has been damaged by something like an EMC spike or something, or you no idea what's happened to this instrument in the past. That's the problem. It could have been plugged into a high voltage supply and it's been zapped with, I don't know, 12 kV or something, and it's just taken all the boards out. And you could I could do this and it looks like it's running through the calibration routine, and it will stop at another problem, like I don't know, EEPROM error or something, and that's, you know, it's another £100. So really, what do you think? What's your opinions on this? Shall I carry on? Shall I try and shall I leave it for a while, try and source some parts that are cheaper, or shall I just plod away at it and try not to replace the board? I might be able to repair this board, I don't know. I mean, I really don't know what's wrong with it, but it's clearly, when I swap this board over to the other channel, the fault goes with the channel, so it's this board. This board's got something wrong with it. I'll have a look on the internet and see if there are any of these about, but it seems to me that most of the boards of this thing are very expensive, and I have to get them from abroad, which makes it even more difficult because you have to pay all the huge customs charges and postage charges. So a bit disgruntled with it at the moment, but I will check all the obvious things like the semiconductors and check the supply rails and things like that. But at the moment it's a bit disheartening, but hopefully more to come. Okay, this is the what is it, A35 board? I can't remember now. It's the input board that's suspicious. This is the screens have been removed. There's a couple of screens that go over these, and these are basically, it's like a differential amplifier. That looks like there's the 0-volt connection, and that's the one side, and that's the other side of the amplifier. And it feeds straight into these filters, preamplifiers, and sort of, I think that's attenuators as well. All these orange-looking jobby things here are relays and switching attenuators and things like that. So most likely the fault's going to be around this area. I suppose after my initial sort of thumbs down and a bit despondent over not getting it to work straight away, at least I know that this is the board that's the problem, and that they're not available. But it looks like some of these transistors are sort of like generic Motorola transistors and things. They've got these sort of double transistors in them. I don't know if you've seen these before. These are basically like two match transistors. They're usually used for current sharing and things like that, current sources. And we've used these at work before. They look okay. Basically the transistors test okay. What I need to try and see if I can find a schematic for the pinouts for the relays. That would be a good starting point, because often when things get zapped, they take out the relays. That happened in the Rode and Schwartz, and it's happened in other bits of gear I've handled before. There are a couple of chips here that look like a little bit harder to get hold of, like this chip here. I don't think we'll be able to trace anything down with that. But a lot of the other sort of stuff looks like fairly common sort of logic. So I'm hoping we can find something. Also, when you go into a bit further into the fault diagnosis and you look at the inputs, it always shows that this board's got a high offset control, high DC offset, and that's controlled by these two pots here. Now, obviously, it's not going to be an adjustment, but it could be an op-amp's blown up or something like that, and it's hard over. I might be able to put this on an expander board, this one, because it's only got, well, it's almost like a floppy drive cable. I can see there the light's not very good. Get some better exposure. You can see that it's like a floppy drive cable, so I might be able to make something up for that, so I can actually run the board out of the unit, sort of thing. So I'm just going to go through and check all the obvious things. I've checked all the diodes, checked the transistors. I'm just going to go through and sort of have a bit of a closer look. There's no obvious signs of burning. There is a bit of signs of sort of rework around this corner here. I don't know if you can see that if the camera was going to focus on that. A bit of rework, a bit of flux there, and that looks like it looks like a decoupling cap. This little decoupling cap here, this little green capacitor, sort of being resoldered to the board, but no sign of any problem with that capacitor. Put it on the LCR and it checks okay. So let's go through a few other bits and see how we get on. Okay, for what I can see, all these transistors are good in this amplifier section here, or this preamplifier section here. Now we've got a number of chips here with the Hewlett-Packard 1858 numbers on them. That's not a problem because there's a conversion charts and there's lots of information on the internet about these numbers, and you convert them to standard chips, so that's not a problem. There's things like this are always a bit concerning when, as I pointed out earlier on, that are probably harder to get hold of. So really, I think it looks like the very front end is possibly okay, and I need to start looking on here. Now there are test points, so I need to dig out the manual and possibly do some checks with the scope. I might be able to actually test these now, because I've got these cages off. I might actually be able to test them in situ with the probe, with the board actually inside its nest. So hopefully that will be okay. Before anyone jumps down my throat, oh, the tantalums are all short. No, they're not. They're fine. These aren't tantalums. These are foil capacitors, or certainly a lot of them are. That one actually isn't. There's another one here that was a foil capacitor, I think. I can't remember where it is now. No, maybe it wasn't. Which one is it? 0.1 microfarad, I think that was a foil capacitor. They all check okay. There's no signs of any bulging. The ESR's good. They're not leaky, and they're showing good capacitance. So it's not a power supply problem. it's if it's a power supply problem, this board will drag the rest of the unit down, and it's not doing that. It's this board on its own. These transistors here are all JFETs. They're all they all show short between their source and drain when they're not conducting anyway, and that's what they're doing. So without actually powering the JFET up, see if it actually sort of turns itself off, those are more or less guaranteed to be fine. Couple of chips here, same thing, 1826090715. We've got 1860138, so is that one the same as that? We've got a standard SN74LS95N common device. That one's the same. We've gone another one there. Actually no, it's a 74LS28N, 74LS595N. A couple more HP numbers there for anyone who's interested. 18580047. Two devices there. That weirdo one there, it looks like a Siemens device. But that's a 182600581. So another Hewlett Packard number stamped on the top of it. Is that another one of those there? Same as we had at the bottom there. 182600715, and same. Probably an LM741 or something similar. Probably nothing particularly elaborate. So if I can find another one of these boards at a reasonable price, I'll just plug the board in. But I think we can almost sort of go through this board and sort of start shotgunning stuff. Certainly a lot of these chips I'm pretty sure are fairly cheap. I don't like shotgunning stuff. I'd like to be able to actually get in there and test it. But of course the expander board is going to be the problem. Might be able to fix that. We've got test points for amp 1 and amp 2, so it's clearly a differential amplifier. And that's probably all it is. One side of the differential amplifier is gone, and it does show a positive or negative offset. I can't remember which one it is, and that's more or less indicative of an amplifier that's biased hard over. This looks like a push-pull output stage here, by the way. This is a PNP and NPN output stage, and I was sort of thinking that's the final output driver. Those transistors are fine, and these current mirror things, they look like they're fine as well. So, as I say, I think that board's okay. So the battle goes on. I'm not going to give up yet. I need to watch the finances. I don't want to spend £1,000 on a piece of equipment that's not worth, not worth any more than sort of 500 quid when it's fully operational. But it's a project, and I know it's a project I want to finish. I've just been doing some sort of basic continuity tests just to see if I can see anything obvious between these two amplifiers. Bear in mind they're exactly the same amplifier. This is the ground connection, and this ground, if you look at the meter there, I hope you can see the meter. You can see the meter quite clearly. That's 0 volts. Okay, so we've got a common ground between these two. This is what I think is a little op amp. I'm just going through the pins. I'm just going to go through each pin at a time. Now this is the this is pin number, what's that? I don't know. There isn't actually pin 1 marked on these. Is that pin 1? So that must be pin, I think that's pin 4. Okay. 660k. Pin 4 on the other side. 1.1 meg. Okay. Not gonna. That could be capacitor or something like that. Next pin shows open circuit. Next device on the other side, 1 meg. Next pin, 507k, 400k cap charging. So yeah, okay. Other one, 1 meg. Okay, not a lot of difference. 446k, 1 meg. Now watch what happens in a minute. 440k, 1 meg. 427k, 1 meg. Now this is the interesting one. 17k, 2.8 meg. Now, if these amplifiers are exactly the same, there's a discrepancy between these two chips. Now I need to try and find a pin out of these chips and find out what they're doing, but that looks to me, if that's the final output op amp, which it looks like it probably is, if that op amp or that op amp's failed, that would cause our problems. So we'll make a bit of headway with this, or I certainly feel like I'm making a bit of headway. So let's get this chip investigated and see what it is. This is the input to the front end of the unit, where the input board is faulty. Now this is the input. It's a balanced input amplifier, and we're looking at the input on both the channels and comparing them by fitting a signal into the front end of both the channels together in parallel. And I'm looking at the moment at this test point 600 here. You can see that there. So that's basically after that op amp U501 and this op amp here, which is U200. Now there is a difference in level when I was fitting in with just a basic function generator. But if you watch what happens now, so there's two channels connected here. The faulty channel, let me just work out which is the faulty channel. So this is the good channel that's going below. So the faulty channel is one below. What happens when I sweep the frequency? Just put the time base up a bit so you can see and try and get some sort of triggering. A bit jittery because there's a lot of noise on the line because I've got the shields off the unit. But when I increase the frequency, and reduce the frequency, the way that rolls off. These are the same points in different amplifiers. See that? So at low frequency, I get a roll off on the dodgy channel. This is the dodgy. It's the good channel. See, that keeps going, but the dodgy channel, which is the one, this one here, is rolling off, and quite noticeably below. What's that? Oh, about 6 kilohertz. So we've got a roll off problem there. This is where I'm measuring down here. This is the good. I've swapped this board over at the moment. This is the good amplifier, which is originally number 1. That's in channel 2 slot at the moment. This is the board here that's got the problem, and it looks different. I've got the cases off the shielding off. But at the moment, we're getting a totally different frequency response at that point. So now we've got to try and investigate why we've got a totally different frequency response there. So I need to move back and see if I can find out where that signal's being lost. This is the chip that controls the various relays for the attenuators and things like that. The attenuators, filters, and DC, AC or DC coupling. I've been checking resistances and comparing them to the two boards, and I'm getting a strange resistance on pin 12 comparison with the good board I've got. And what I've sort of tracked down to now is if I do a continuity check across one of the wire coils of these relays, we've got about 300 ohms, and you see that 12 is feeding a bunch of 4 relays in parallel, as you can see there. Now on the good board it's about 80 ohms, which is, you know, about right. 4 80 ohm resistors, sorry, sort of 4 300 ohm relays in parallel will give you about 75 to 80 ohms. And on the bad board I'm getting about 120. When I compare it with this one, which should have exactly the same resistance on, I get about 75 80 ohms on. This is on the bad board. The bad board is showing 75 80 ohms on this point, which is correct. It should show exactly the same. So that's saying to me that one of those relays is open circuit. So I think the only way I'm going to find that out is to probably, short of cutting tracks, which I don't want to do, is pull the relays out and have a look. But they control the 40 dB attenuator, and of course if that's in, because the levels are different on the inputs of these amplifiers, when I'm looking at them side by side fitting in the same signal, the levels are different. So there's a good chance that there's something wrong with the attenuator circuit on here, and the relay's packed up, something like that. So the next step will be to try and work out which relay it is. I don't know if I can lift. I don't. Yeah, so this is just all go straight back to the 5 volt supply. The other option is to try and feed a supply straight into the relays and find out which one isn't activating. That'll probably be the easiest thing to do. So that might be the option next to carry out. But it certainly looks like it's the very front end of the amplifier that's the problem. Okay, found out which relay is. What I did was I stuck the 5-volt supply here and grounded this pin to the other side of the power supply and activates all the relays. Sure enough, K209's not working. All the others are, you can see their contacts closed, but K209 doesn't do anything. And that's possibly because K209's got an open circuit coil. So what I'm going to try, it sometimes works, doesn't always work, I'm going to resolder K209 in, see if that fixes. K209 is this relay just here, and that feeds off into the amplifier. What's possibly happening, from what I can see, is the signal's just coming through, down through here, and then being passed through, the filter network's being bypassed, and it's all sort of, this is all for flattening response and bandpass filtering things. And that's what we saw earlier with the roll-off and the frequency response. So let's resolder the coil of K209, and if that doesn't work, we can always have to try and trace down a relay, which could be interesting because it's a bit of an odd-looking relay. So let's do that and see what that does. I've got the offending relay out. This is a little Koto. Part number is 29000022. Can't find anything like that on the internet now. It's probably also an obsolete part. I found another Koto item that should work, and that's been ordered on eBay. I'll just show you. So the two contacts are the two the coiled contacts are here. Open circuit, totally open circuit on the meter. Therefore, and it's a normally open relay, so you won't get any contacts on the read anyway. I've tried the old trick of heating up the pin and trying to melt the solder if it's gone there, but I think it's actually gone inside the winding. So that relay is shot. Now that could possibly be one of the problems I'm getting with the calibration error on channel 2. When it does a self-calibration and feeds signal into its front end, it sees that the attenuators, well, it's the read's open all the time, so the signal doesn't get through. So there's a good chance it's phoning it on that. So hopefully get that read relay in, and then maybe that board will be working, and then all it really boils down to then is getting the rest of the thing working, getting it calibrated. We've definitely got a big improvement with that A5 board, and we've lost all those data bit errors. So there was a problem with that board. So initially I thought, bugger it, it's not that board. I just spent 100 and God knows what quid. I think we've only got a few errors left now, and they've all come back to a calibration error, which is because basically that board won't calibrate because obviously there's a problem with it. Distortion on that board. There's a problem with the board, and also it says that there's a digital problem with it, and I think that's basically because it can't control the relays. I think it probably knows there's a problem with. I'm not sure, but I think that's all it is. The DACs, I'm pretty confident, work. The DACs are basically or the ADCs, analog to digital converters, basically control that board, and if you swap those over, the fault stays with this board all the time. Doesn't matter what you do with the other boards. So I think we're homing in on the problems, and I'm just hoping now that once we get somewhere with this read, put this new read in. Maybe that'll come Monday or Tuesday probably. It's Saturday this evening, so order that. That's been ordered, should I say? And then we're just waiting for the parts to come. And then we'll have another go, and hopefully once it's up and running we can move on to something a bit more rewarding. Right, for the time being what I've done is I put the board back in, and I've actually sort of linked out that relay. So even though the relay will be on all the time rather than being off, it might give us a better idea if that has anything to do with the problems on the channel 2 error, the channel 2's that's failing all the time. So let's power it up. There's lots of fireworks going on tonight. That's not the workshop, it's not the unit popping. see what this does. So that relay that I showed you previously has been linked out. Oh, it hasn't come up with the error message yet. Oh, this is an improvement. We're getting much further through the self-test than it was before. It would have failed by now. It's still running through the diagnostics. It's bound to still fail because it's got no control over that relay, but wow, we're definitely getting somewhere. Okay, system fault calibration error, that's fine, but we've got a lot further. Let's have a look, see what we've got now then. So service test input, front end adjusts. We don't need to do that yet. We need to check the ADC, and this is where it failed before. And it will fail on distortion. It will fail on distortion on channel 2 and a few other things on channel 2 as well. Front end passes. Oh, brilliant! So that part of the fault looks like will be fixed with the relay. There's still a problem, obviously, because we haven't got a relay control. Let's do a full test all, see what this does. Ignore that at the moment, it's still running through the diagnostics. Takes a little while, this test. It's doing a lot more relay chattering than it normally does. It usually, because it never ever gets this far. God, blimey, it's taking much longer than it normally does. Let's have a look at the results at the end, will be interesting. Quite a long diagnostic program by the looks of it. Okay, so what we got on calibration accuracy fails and calibration. That's brilliant. So that's now saying that just because it can't get control of the attenuator, that's probably the only fault. So we've reduced our faults down to 2 from about 6 that we had initially when we got the unit. Oh, brilliant. So I think we're getting somewhere, and when that relay comes in, that might fix all our problems.